So this is the snippet of the same thing, session ID, timeout, yeah, all that information here. One more thing I need to show you guys, which is, okay, so this is that yellow column, which was in my slide. So if you see this arrow pointing downwards, you can just click on it, columns, and you can see here how much flexibility we have. So we have a lot of options just to see in the monitor logs. So whatever the requirement is, you can always put a filter here and you can see that information here. So you can put a column for session ID, packets, whatever you want to see. It's very powerful. And that's why I mentioned that in the beginning that around 80% of the issues you can just easily figure out just by logging that what the firewall is doing to that traffic. So it's very powerful. Okay, moving on. So there could be a short sessions on the firewall. So when a security policy action terminates a connection, typically you will have 15 seconds of time in the time wait state. So this is one of the TCP state. Even though the connection is terminated, it still will be visible in the session monitor until it times out. For UDP, there is no connection termination because it is a stateless protocol. UDP sessions always time out. The default for UDP is 30 seconds, during which time the session should be visible in the session browser. And once it timed out, you won't see it in the session browser because it just shows you the live sessions. The session browser allows you to view active sessions currently passing through the firewall. Once those sessions end, you will see them in the traffic logs. So if something is not there in the session browser, you can always go back and look in the traffic logs. It will show you all the historical data. So session blocks on session setup will not appear because there will be in slow path. I'll talk about slow path and fast path later in the slides. Just to find a matching policy, use counters, or you can use a custom policy to log the traffic. Okay, so this is the high level system state. So we have seen everything in the monitor logs and we are still not able to figure out what's happening based on the logs, based on the session browser. We are still clueless that what exactly happening with the traffic. Then we'll move forward towards the PCAP just to see PCAP and the global counters, which will give us more information. And these are, we have to do this in not in every scenario, but there are few scenarios where all these logging stats, it doesn't help us. So we have to just go up in the troubleshooting ladder. For the first 10 seconds during a session timeout, logs may show nothing. However, the session will be visible in the session browser because remember, in the security policy, we are logging at the end. So you can see the session in the session browser, but you won't see anything in the security policy. Sorry, the monitor logs. Once you find the session record or traffic log, you can see whether the session was allowed or not allowed. You can also use cross-reference policy matches and evaluate why the traffic is getting matched and why it is not being logged. Okay, so this is the log session and this is the reason why we don't see the session when it's active. Okay, moving on to data plane counters. So we have we are trying to troubleshoot something and we have leveraged all the logging features and we still cannot figure out what the problem is. That's when we start using the global counters, which is again very powerful, and it can give you more information related to the firewall drops. So we have counters for every function why the firewall is dropping the traffic, and you will see all those counters incrementing based on the filter we have in the monitor logs. Okay, so again, we have seen the logs. We could not identify what was wrong. Session browser did not help us. That's where we work on using the global counters. So if the traffic is getting dropped, we need to find out where it is getting dropped. Is it happening at the passing error because of passing error? It is because IPv6 not enabled. Remember, I talked about it. We have to enable it in globally on the firewall. So if it's not enabled, we can see the firewall will drop those packets. Is it being dropped during the slow path, like during a policy match, or it could be some kind of land attack? Is it because of routing error? Next hop does not exist because of the route flapping, or is it a bad route? So there could be a lot of reasons. Uh, and using global counters, we can actually find out that why it happened. So what exactly we look in the global counters? So you typically want to run a command which is show counter global. I'll show a demo later command, and that will show all the counters on the firewall which are being incremented. We can have a delta feature added to the global counter command just to see the changes that happened since the last time we ran the command. So we keep on running the command just to narrow down what specific features and functions are being hit, where do we see the increments, and why just we see the increments for those features. So it's very powerful, and I'll show you the demo in about a minute here. Just to verify the routing, you can use this command, show routing fib routing lookup. This will give you information about the destination interface, which firewall is going to use. If the reason is still not clear, after taking a look at the NAT and the routing, then we'll leverage the packet capture with Flow Basic. So I'll show you how the global counter looks on the firewall. Okay, so this is the command we normally run just to see the counters. So if I press enter here, it's gonna give me the list of all the counters, which is not very useful. So I'm repeating the same command again, and we see different stats every time. Okay, because the value keeps changing, but just running it without a delta option is not useful, and we are just not gonna get anywhere. So what we do with this, excuse me here. So by adding this option, we will just see the changes that happened last time we ran the command. So if I run the same command multiple times, see, now we don't have a more option at the bottom of the command because it is just displaying the changes which happened after running the command last time. So only these functions have changes in them, and that's why we see when we run the command again. All right, let's go back to the slides. Okay, so this is the same command which we have run here. So over here, it's has a filter for packet filter. So this packet filter is when you configure a filters for the interesting traffic in the GUI of the firewall. So this is referencing to packet capture option over here. So when you add the filter here for any of the interesting traffic, we'll just see the counters for this IDs which we have here. So it could be any source, any destination. So when you run the command in the CLI, okay, so these counters will only be presented just for that traffic which we have mentioned in the IDs. Okay, so that's why we have this option here, and it's very useful when we are trying to troubleshoot a flow of traffic which is not working the way we want it to work. Okay, when you add the delta, you will see the changes, but these counters are just for that filter which we have applied in the GUI. Okay, based on the filters, we have a different columns here. Name of the counter, okay, it could be packet received, sent. We have a lot of counters, and based on interesting traffic, we can look for that specific counter. What is the value? What is the rate? So this rate is, this is the total value, and this rate will be the current rate. Uh, what is the severity of the counter? Is it just for information? Is it a drop? What category is there? And there's a little more info about this counter, which is packet received. So packet received, you can always use the description field on the right side. There's one more thing I want to talk about here. So let's say if you are trying to troubleshoot something and you see a drop over here. So we can have a filter for drop also. And if you see the drop counter is incrementing for some reason, so don't think that this is causing the problem. There could be n number of reasons on the firewall and why it's actually dropping the traffic. So when you're trying to troubleshoot something and you see there's a drop, so it doesn't necessarily mean that that drop is seen because of a problem. It could be any reason. So you have to just narrow down your filters and look specific for that global counter. So you have to correlate everything. We can't just, look for the drop and okay, this is the reason and it's not working. It could be benign also, this drop. So just don't be misled by seeing the drop over here. Okay, so this is the same command here again. So it is just specific to that packet filter. We are seeing the counters here. And when you include delta here, it will reflect the changes after running the command last time. Okay, we can have a match drop here. So if you want to see the counters just for the drop, you can run this command with the pipe. So whatever you enter after a pipe, you are actually feeding that into this command. So it's just gonna match the drop for you. So you can have a match on info, error. So based, and it depends what you are looking for, and you can just put a filter over here. Normally we don't use the match drop. We want to see all the counters that are being hit, so we normally don't use it, but if you are interested, you can always have this option. All right, moving on. So once you can verify that the problem traffic is reaching the firewall and is being processed, typically you then attempt to define exactly what the traffic actually is and discover the policies to which the firewall is matching the traffic and why. You then can just adjust your policy rules to match to the target traffic. Your understanding of the flow logic of the firewall will help you to put all of the issues related to this simplified process of diagnosis and resolution in the correct order. So these are few of the questions you ask yourself. What exactly happened? Traffic missing intended policy? Is it hitting default interzone policy? Are we doing logging for interzone? Because by default we don't do it, because we don't want to do the logging for the interzone. But for troubleshooting, you can do it. Allow ICMP does not work as intended because it has a ping, its own application. So look for that application. Is it allowed? Is the telnet allowed instead of SSH? So these are the things you have to ask based on the problem you are facing, because telnet and SSH, these are two different protocols, runs on different port numbers. Uh, one is secure, one is less secure. So yeah, so these are the questions which should uh, keep coming while we are troubleshooting any scenario. Okay, moving on. So we have covered logging, we have covered counters, global counters, and we still don't know what the problem is. We are not able to correlate. Then that's where we jump into taking the PCAPS. So this is the third part where you want to leverage the PCAPS to troubleshoot a scenario. Okay, so high level system state, okay, logs. So just want to add info here with the high level is how the system is behaving, the functionality, CPU, memory, disk, all those normal things which you want to take a look at before troubleshooting any scenario. Because if we find out later there was some performance issue, then all of this will not make sense, because there was a performance issue and that was causing drops, and it could be anything. So the first place you always start look for the system state. It should be healthy and it should look nice when you're trying to isolate and troubleshoot the problem. So we have taken a look at the logs. It didn't help us. Session browser did not help us. Global counters, we are not able to correlate everything. That's where we go into a deeper troubleshooting, where we can take PCAPS and flow basics. And after taking PCAPS and flow basic, we still cannot figure out what's happening. Then it could be there's a possibility that it's not a firewall problem. Okay, moving on. So the traffic is still dropped. You are not sure why. And then we suspect it's not a firewall problem. It could be application issue. It could be a intermediary device between the firewall, between the client, between the server that's causing the issues. We are not. We are just seeing one-way packets. Counters are not helpful enough. We are getting inconclusive results. If checking global counter, traffic log, session, everything is normal, then just go and look for uh, things like offload traffic, where the traffic is not offloaded correctly. Okay, and if you think offloading could cause the problem, we can disable it temporarily so that we can see all those packets in the packet capture, because when we have offloading enabled, we won't capture all the traffic because that's offloaded to the hardware. We'll just see the initial session and then it will be transferred to the chip, which we won't see in the packet captures. Okay, so the packet captures, it actually gives you the truth, or you can say the real time info of on the wire, because packet captures never lies. We can see everything clearly, what's happening, and these could be used for troubleshooting wide range of network related issues. So we should always use the narrow PCAPS. Never try to use a broad PCAPS, which can impact the firewall performance. And be cautious when you use packet captures, because if you leave them on for a long time, it can degrade the firewall performance. And never take broad PCAPS, especially during the production hours, because it can affect the performance of the box. So always do it in your maintenance window and try to use narrow PCAPS. So packet captures can help you troubleshoot enterprise application protocol levels behavior that are causing problems on systems other than the firewall. Packet captures can be invaluable to forensic or threat investigation that may require sampling of malware behavior, analyzing non-standard or other suspicious communication. So it's a very powerful feature which we can use on the firewall just to see what exactly firewall is doing to that traffic, at what stage it is being dropped. If yes, why? Because of the policy, because of the missing packets, is there latency, how the application is behaving versus how it should be behaving. So there are a lot of questions we have to ask when we are taking packet captures. Okay, so this is the snippet from the monitor packet capture from the GUI. So this is the managed filter. So the max IDs we can have 4. In this case, we have just configured 2. So this is source, destination, source port, destination port, protocol. So you can make them as narrow as possible so that we just capture interesting traffic, which we really want to see. We don't want these to be 00 going to 00. There will be a broad, it will just pick everything from the wire and can cause performance degradation. So always narrow down, use the source IP, destination IP. If you are not sure about the source port, leave it empty. Destination ports are interesting traffic ports which we normally know. So port 80, for example, here is just for HTTP. The protocol will be TCP here. Sorry, excuse me. Yeah, the protocol number is 6 here. If you don't want to include the non-IP traffic, you can just exclude it. I'll show you how it looks like on the firewall in a while. And do you want to capture the IPv6 traffic? So these are all the options here. Then for the return traffic, we normally mirror the IDs. So instead of the same source putting here, we just mirror these source and destination IP addresses. So 200.33, and you'll see the IP over here is different because it could be a NATed IP address. This is a private IP. So the return traffic will hit on this IP address. So we want to see that. Okay, if you don't want to do that, you can just put the same IP here and the firewall will do the natting, and then you can compare the traffic in the packet captures. So Yeah, if you can have a netted IP address here or the real IP addresses. Just it depends what you want to see, what you are looking for. Okay, so blank fields 000, it just for any address, so it will just capture everything. Okay, bi-directional filters for NAT, and we can have max 4 filters. Okay, there's a pre-pass match option over here. We normally don't suggest customers to use it because uh, it's normally used when we are troubleshooting some scenario. So the packets for which we don't see the session IDs, uh, this will match using this pre-pass match option. So pre-pass match is a feature that can capture all files before they are processed by the engines running on the data plane, which can help troubleshoot issues when engine may not be properly expecting an inbound traffic. This option should be used only if instructed by support team and on low volume time of day, as it will capture everything. So just be cautious when you are trying to use this pre-pass match option. Okay, moving on. So when we take the packet capture, uh, we have to enable the staging. So by staging, I mean at what stage the firewall sees the traffic intercepted, and at what stage you want to see that. Okay, so where it could be receive stage, that is post passing receive traffic. It could be firewall stage PCAP, which includes packet that establish that are established, or it's gonna match to an existing session, or it could be a new session where the firewall is actually applying the different policies before setting up the session. Okay. Once the session is established, we do the layer 7 inspection for content and other stuff. And once it is done, we transmit the packet out. So on the firewall, we have 4 stages: receive, firewall, transmit, and drop. Okay. So at any stage, the traffic will be dropped, and just to find out why it's dropped, we have to look deeper into the packet captures correlated with the global counters, and then compare it with the PCAP. And sometimes there's a scenario uh, where you see the drop and receive PCAPS. So that doesn't mean that it is not supposed to happen. It just whatever the firewall received at the receiving stage, it doesn't matter. Later it dropped it, but it has received it. So it will always report it to you that I've got this, but I've dropped it. So you can see receive and drop at the same time. Okay, moving on. Okay, so using packet capture stages. So I'll quickly show you the stages on the firewall, how it looks like. So over here, we can just add the filters by having one. So these are the different options we can use. What physical interface you want to capture it on. You have that flexibility. Source, always use the IP, never use 00. Okay. Port, source port. If you are sure about the source port, you can put it over here. Otherwise, just leave it blank. And destination port 80. For protocol, we don't have a drop down here, so we should remember them, like for UDP 17 or TCP 6, ICMP 1. So we can use those protocol numbers. For the non-IP, we have 3 options here. Sorry, 4: none, exclude, include, only. So depends what you are trying to achieve here. You can select the correct option. And if you want to capture IPv6, and then put a ID2 for the return traffic because of the NAT. So just mirror this source and destination IP address and the ports as well. Okay. So in this case, I have this. Okay. So once I turn on the filtering here, that means the firewall will start capturing the traffic just for this source and destination. But by turning the filtering on, the match is happening. The real packet capture is not turned on yet. Okay. So to turn on the packet capture, I have to do this, change it to on. Okay. But before turning packet capture on, we should always add staging here. So this is the staging I was talking about: drop, firewall, receive, transmit. So you add them one by one because we don't want it to be merged. Okay. We want to see at what stage the traffic is being dropped. So we have to split them apart and we have to use all 4 stages, but to be written down in a separate file. So just use a different name. Anything you can put here, it's just a file name. Receive. Okay. RX. And similarly, we can do that for the TX, which is transmit. Sorry. Transmit TX. Okay. We also have an option for packet count. Let's say if something is really critical and you don't want to run the packet capture for a very long time. So in that case, you can have, how many packet you want to capture, packet count, byte count, but most of the time we are not sure about it. So we just keep it blank. Okay. And let's say if you want to merge a receive and a transmit packet capture. So there's an easy way of doing it from the firewall. Select the staging. So staging should be correct, which is transmit. And for the file name, use the same name as receive. Okay. So the firewall will merge these files. So receive and transmit, they both will be merged into this file RX. So if I turn the packet capture on, all these files will start to write over here. I don't know if I have an interesting traffic, but let's see. Okay, so you have to tweak these settings based on your requirement. So just to grab everything on all the interfaces, I have removed the interface and let's click. I have removed the protocol and let's see if we capture this. Okay, so now we have captured this. So once you run the packet capture on, you will see the capture files here. And if you keep refreshing, the size will keep incrementing based on the amount of traffic the firewall is seeing for that source and destination. So 5718, it's not incrementing. So maybe later, but yeah, this is how it looks like. Once you are done, always turn the packet capture off, turn the filtering off, and then refresh again and download the file by click on the file. And this is the downloaded PCAP. You can examine that. So since I named it with the same file name, it's highly likely that the firewall has merged receive and transmit. If you don't want to merge them, use the different file name here. There's another way. If you are using a different file name, you can merge that PCAP in the Wireshark. So this is the Wireshark. So there's an option on Wireshark, file merge. So if you are using different file names, you can always merge from here and then you will have a better picture what exactly happened with the traffic. Okay, so yeah, these are the staging we have on the firewall. And once we have this enabled, the firewall will start marking these sessions because of the packet capture filter we are using here. So if you run this command, debug data plane packet diag show filter mark session, this is how it will look like in the CLI. So these are the mark session. So just to clear these mark session, we can run this command, clear filter mark session all, because we want to start from the beginning. We don't want the firewall to show something historical. So always start fresh, start from the beginning. So we don't have to, repeat our efforts. We want to do it once and do it right. All right. So we'll talk about which capture stages to use. So normally we use all the stages. You can skip the firewall stage because it's more of the how the firewall is actually processing the entire traffic. But if you don't want to use it, you can at least have 3 stages: drop, receive, and transmit. These are mandatory. You need them. So you can skip firewall sometimes. It depends. But yeah, but normally we just put the filter for all the 4 staging. Okay. So internal flow of the firewall, it's normally at the firewall stage and the drop stage. Session on the wire, it is at receive and transmit stage. Then transit time across the firewall, you have to assess the timestamps from receive. So compare the timestamp with the receive. So firewall first receives the traffic and then transmits it. So in that time, what exactly happens? So it is very useful to troubleshoot the latency related cases where the firewall actually adds the overhead and there could be a delay for few seconds. So you can compare the timestamp when we received it and when exactly we transmitted it. So we can always match ingress packets with the egress, compare receive and transmit stages. There are few packets which are generated by the firewall, like response pages and things like that. So those will be recorded at the transmit stage. So when you examine something like a page is blocked for a malicious URL, so that page is coming from the firewall. So you will see that in the transmit stage. And for the any drop packets, you have to examine the drop PCAP. So anything can be dropped by the firewall. There are n number of reasons, but just to troubleshoot, look for the interesting traffic. If it's there, part of your drop packet, then you have to, find out a reason why the firewall is dropping that. Okay. Configuring packet capture. So I just demonstrated this on the GUI of the firewall. Yeah, just be careful of not using pre-pass, use narrow filters, and yeah, pretty much it. Okay, moving on to the flow basic. So once you are done with the taking packet captures, you can move into a flow basic stage where we can actually see all the activity that's happening behind the scenes by the firewall. How the firewall sees the traffic, what exactly it's doing behind the scenes. We have a lot of verbosity when we implement the flow basic. They are not needed in most of the cases, but if they are needed, they are really verbose and give us a lot of information. Okay, so these are few settings which we have on the CLI. So debug data plane packet die clear all. It just clears all the setting which we already have. Okay, then we can configure a filter. Remember, these are the IDs which looks like this in the CLI. So there's a way we can configure these in the CLI, but I highly recommend you stick to the GUI, because in the GUI, we can clearly see the what we are actually defining. Over here, we can make mistakes, because these are the commands which will show up when you use a tab completion on your keyboard. But it's I would suggest you to just use the GUI, because these are the long commands and we can easily make mistakes. So if there's a sensitive environment and we are trying to packet capture, we are trying to get a packet capture, it's always healthy and safe to do it on the GUI. Okay, so this is the command. You can put the filter. Then to turn on the filtering, you can just run this command. So this is another way. It depends on the scenario. Let's say for some reason you lost the GUI access, but you still need to capture something on the firewall. How would you do it? So in those cases, you can use these commands, and it's just gonna give you the same result. It's just a different way of doing a PCAP. Okay. You can add the stages. Then with this command, you can set the capture on. If you want to turn off the packet capture, you can just set capture off. If you want to view the PCAPs in the CLI, this is the view PCAP command, and it will just show you whatever you have recorded in the PCAPs. Okay. Once you are done with everything, you can just debug data plane packet die clear or the staging, and it will just go away. Okay, so we have talked about logging. We have talked about global counters.
Hey, Arun, I just wanted to check in with you. Are we at a place where we could possibly take a break for 10 minutes, or do you have not much more content?
I think we are hitting the last section. So yeah, we can take a break. 10 minutes is fine.
Okay. Ladies and gentlemen, I have us about roughly 22 after the hour. Let's come back at the half-hour mark. So let's do an 8-minute break if we could, please. Arun, if you could stop sharing for me for a brief moment.
Yeah, sure.
I'll just go ahead and put up a share screen. We are going to be taking a 10-minute break, although realistically an 8-minute break.
All right.
And let's take a few, and I'll warn everyone when we're about halfway through the break time. Thank you very much. We'll talk to you in a few.